So this is mainly just a summary table of whatever that's shown in the flow chart. This will be available in the document itself as well. So yeah, if you need a quick reference, then you can actually read through this. Okay, on the work demarcation on what does the build team have to do and what the provisioning team has to do. So that's just a very simple rule to say on the part of the network, if it serves multiple customers or it affects multiple customers, then it's supposed to be a build job. The provisioner will only install any part of the network which only serves one single customer. So for example, your lead-in or your IFFP that serves multiple customers, so that's a build job. Same thing with your risers, same thing with your internal FATs. For your drop cables, that installation only serves one single customer, so that is the provisioning job. So it's just a very simple rule in that. Okay. So in the updated deployment standard, I'll have this section on what do we do for year 1 and year 2 network. Because the MDU deployment standard did not come out until the start of year 3. So in year 1 and year 2 deployment, we have a lot of MDUs as well, where we left the communal infrastructure at the boundary of the MDU, and it does not comply with these standards. All right. So we are not saying that that's totally wrong, because at that time we didn't have any standards, so even Chorus ourselves did not know what's happening. So it's already there, and we have to deal with it. Right. So this is basically the standard of how to deal with it. The simple rule is whatever that you have left in the boundary of the MDU, use it as it is. Do not need to augment the network to make it compliant with the current standards. So for example, if you have a medium-sized MDU with 40 customers within, all right, and you left a 96 fiber cable at the boundary, coiled up in the pit. So rather than changing it to comply with the current standard, which is short fiber lead-in and installing a splitter in the MDU, the year 1 and year 2 design will probably have designed a capacity in the cabinet to deal with that 40 customers in the MDU. Right. So if you were to augment the network, it means that you have 40 customer connection capacity in the cabinet which will not be used. It will just maintain empty, right, which is not efficient at all to use the capacity. So rather than changing the network design, use the cable that you have left at the boundary. So in that scenario, you have 40 customer connection, you have 96 cable coiled in the pit. Extend the 96 cable into the MDU, terminate it into a Booty M, and do a point-to-point splicing within the Booty M and install a riser up the building. And then you provision the customers using the splitter in the cabinet. So, which means that whatever you have in the network, use it as it is. You don't need to change. So for example, if you have an air-blown network and you left a 26-way microduct at the boundary, extend the 26-way within it, terminate it into a Booty M, and then you can install either your riser fixed fiber cable into the building, or you can install microduct from that internal FAT as well, and blow 2-fiber EPFU from the cabinet into each customer connection. So whatever that's left at the boundary, just use it as it is. Okay. Another new design rule for MDUs is that in some buildings, it may have existing lead-in cables, which potentially might be used for a point-to-point service, for example, HNS service that is not going through NGA service. So this standard we're talking about, can we reuse existing cables or fibers into the MDU? So once again, we split it into the 3 MDU sizes, the small, medium, and large, based on the same number of custom connection. And we talk about, for example, for small MDU, we need to have at least 2 fibers per customer. Okay, so if you have 2 fibers per customer, then you can say, yep, an existing service and they want to change to NGA service, that existing working fiber will become a spare, which you can then use to provide NGA service. But for a medium and a large size MDU, if it's a working fiber, you cannot straight away change it to an NGA service because it affects multiple customers. Right? So you can't turn it off because you turn off other customers as well. Which means that you need to think about, are they spare fibers rather than are they just sufficient fibers. So for a medium-sized MDU, we need 12 spare fibers. For a large-sized MDU, we need 48, which is basically consistent with our lead-in standard. Alright. So if they are spare fibers, then we need to take into consideration, does these fibers go all the way back to the exchange? Right. You may have, for example, 12 fibers going into the building, but in the LBA ring, you may not have that 12 fibers which ties all the way back to the exchange. Right. So we need to take that into consideration that if we have 12 fibers from the exchange all the way up to the MDU. Alright. If the condition is that we have 12 fibers going into the building, but we do not have sufficient fibers all the way back to the exchange, then we consider it as having no existing fibers. Right. Then we just install a new lead-in into the building. Okay. Is that quite clear? Right.
So that information will be provided by the designers, right?
Yes, the designers will have to provide that information, which basically, because this is dealing with fiber capacity in the LBA ring, so probably the planners will have to provide that information as well, because they may be spare fibers, but they may be reserved for some other service as well. So the planners will have to provide that information. Okay. So this slide is basically talking about how do we manage fibers within the app FFP. Okay, and this is for a small MDU. So for a small MDU, we utilize the splitter in the communal side, right? So for a small MDU, in this example, let's say we have 4 customer connections. So we lay 2 fibers in an SC tray for each customer, right? So for example, we have unit 1, unit 2, unit 3, unit 4 for the MDU over here. And in this case, we are blowing, let's say, if we blow 2 fiber EPFU to each unit, that's quite straightforward. We just lay 2 fibers in each tray for them. But what if we blow a 12 fiber EPFU to that building? So you have 12 fibers, you have 4 customer connections. That means you only use 8 fibers, and you have 4 spare. So what do we do with that spare fibers? So with the spare fiber, we route it into an SE tray, which will then be labeled as MDU spare fibers. So for that 4 spare fibers, we install it into a short length of fork tubing, label it with the MDU address, and just call the fibers within that tray. So potentially you may have spare fibers from multiple MDUs. So that's why we need to install it into a short fork tubing with the address so that we know all those spare fibers, which MDU is it going to. Okay. You do not need to, if let's say you have a meter of fiber, you do not need to sleeve a whole meter of fork tubing. You just need a very short length where you can just put the address labeling on it. Okay, so for a medium-sized MDU, if we are to install a 12 fiber cable or 12 fiber EPFU, we just lay all the fibers into an SE tray and splice all 12 fibers. It's quite straightforward.